Good day, all. Thank you for joining today's webinar entitled Supercharge Your Disaster Recovery Strategy with Global Server Load Balancing. My name is Rochelle Wheeler, and I am joined here today by Nasir Hussain. Before we begin, I'd like to cover a few housekeeping items. There is a questions panel located in the lower portion of your screen. You may need to expand that panel by either clicking the plus sign or the down arrow for a full view. We will take questions at the end of today's presentation, so you are encouraged to submit those questions via the questions panel at any time. Today's session will be recorded, and the recording will be made available at its conclusion. In addition, to receiving the recording, you will also receive access to our global server load balancing checklist, which can be leveraged when deploying or making major changes to your global delivery strategy. I will now hand today's presentation over to Nasir. Nasir?
Awesome. Thank you so much for that introduction, Rochelle. Hello, all, and welcome to today's webinar, Supercharging Your Disaster Recovery with Global Server Load Balancing. I know that's a mouthful. Try saying that 5 times over. As Rochelle mentioned, my name is Nasir Hussain, and I am one of the solution architects here at Progress Kemp. Just a little bit about me. I've been working with load balance for almost a decade right now, and I'm super excited to go through this presentation with everyone. Before we actually get into the webinar itself, let's go a little bit about Progress, who Progress Software is. So Progress Software has many different products under its belt, be it an application delivery controller, a LoadMaster or load balancer, which offers on-prem and cloud-based solutions, infrastructure monitoring, forensics level monitoring performance, network cybersecurity with automated remediation capabilities, and comprehensive scalable automation for configuration, deploying, and managing an org's entire application infrastructure, no matter where it may reside. Okay, now that we've done with the introductions, let's get into the meat of the topic, global server load balancing. So to start off with, what is global server load balancing? We'll go through the technical discussion first and then go into the day-to-day practical applications for it. So global server load balancing, also known as GEO or GSLB. Now, from here on, I will interchange between GEO or GSLB just to save the hassle of saying global server load balancing through this entire presentation. So what it does, it builds on core load balancing techniques to provide a resilient flow of network traffic across multiple data centers and cloud providers separated around the local geographical location, like in North America, South America, parts of Europe, or across the globe between Americas, South America, Europe, Asia Pacific as being the regions. So in layman's discussion, what does this mean? Well, we provide high availability between your data centers to ensure that we are optimizing traffic redirection to the closest physical location in the event of a failover to ensure business continuity. Now, you're going to hear me referencing business continuity a lot during this presentation because that's the whole purpose of GEO, is to make sure that we do not experience any sort of downtime in our environment for our organization. So what are some of the benefits of utilizing GSLB? The first and foremost is performance. We ensure that all sites are monitored for performance issues and that traffic is routed to the other site if one particular site is overloaded. Scalability. Ability to easily scale across multiple sites. If there is a spike in a specific site due to local event or catastrophic failures, the load is distributed to a side where the servers are less busy. Now, in the same breath, scalability can also mean about business expansion. If you've acquired another company, if you are bringing another site online, it's extremely easy and simple to add that site to our already existing workloads without having to do massive changes. Resilience. In the event of a disaster that leaves one of our sites unavailable, redirect traffic to our other sites. And when the issue is resolved on our primary site, the traffic is then redirected back to it. So if there was a major catastrophe and we need to spin up a new site, or we already have an existing site, we can ensure that traffic is flowing without affecting our customers. And last but not least, regulatory compliance. Now, there are some countries, some bodies that require that the clients are connecting to that specific local geographical location. So what we want to ensure is that those clients are only connecting to those specific locations. So this might be something that's a requirement in the EU, where the data that the customers are accessing, or the data with the customers' storage, is local to the European region, and that it should not traverse across the pond to North America to access those resources. GSLB is going to help ensure that we are compliant at all time. Okay, so now that we've discussed a little bit of what GSLB is, what are the benefits of GSLB, let's take a look at how traditionally without GSLB, the flow of information works. So in this example that we have over here, we have two subnets, two end users trying to access our application, which is app.domain.com. So the client then makes a request to the DNS server. The DNS server has a list of A records that is associated with those FQDNs. The DNS server looks through those records and provides the adequate A records for the client. And then it sends that request back to the client. The client then goes ahead and makes a request to the backend application server. Now here's the caveat. In this scenario, one of our application servers is down. The 10 subnet, the 10.68.130 subnet application is down. But the DNS server does not know about this. It doesn't have the ability to do advanced health checking to keep a pulse on the back-end application server. So in this scenario, the clients on the 192 subnet has no problem accessing the resources, while the clients on the 10 subnet are getting intermittent issues. What this results in is an uptake of tickets being created for our IT admin staff, where sometimes they're able to get to the resource, sometimes they're not able to get to the resource. It just depends on how the DNS server is serving up the request. So sometimes the 10 subnet may get access to the resource because they may get a response to the 192 subnet, but the server that's on the 10 subnet is actually down. So this is going to cause intermittent issues and causes a lot of grief for our IT admin staff. So now, how can we utilize GSLB to resolve and remediate this issue? So again, we're going to use the same scenario as we did in the past, but at this time, we have a load balancer attached to it. So again, the first step is always going to be the same. The client is going to make a request to the DNS server. Now, one of the things that we should mention is that in the previous example, the DNS server was the authoritative responder for that FQDN for that domain, meaning that the FQDN had the A records in its table that it can respond with. Now, when we are utilizing GSLB, we have essentially made the DNS server a non-authoritative responder. What that means in layman's term is that, hey, I know a guy. So when the request comes in from the client, app.domain.com, the DNS server receives that request and then in turn goes ahead and makes a request on behalf of the client to the load balancer. The load balancer looks at the information, the query that it has received, and it responds back with an IP address. The DNS server then sends that back to the client, and the client is able to make a request to the load balancer, which in turn is going to route that to the correct resource pool on the backend. Now, what happened over here? Well, one, the GSLB was able to determine that our backend application is actually down. and it is not working. So it's not in any capacity to serve traffic. So it will not go ahead and send that IP endpoint back to the DNS server. This solves a lot of issues that we just discussed in the previous example. Additionally, I just want to put a little caveat over here. Now, as we're going through this presentation, you might have noticed that the client did not make a request to the load balancer for the request. It was the DNS server. Well, over here, just on a very high level, there are two ways that which we can go ahead and make a query. It's either a recursive or an iterative. A recursive means that the endpoint or the last hop, in this case, the DNS server, is going to go ahead and request the resource from the authoritative node. So when in this case, the DNS server, all the requests is going to look like it's coming from the DNS server. Don't worry about that. I know some of you might be worried that, hey, listen, if all of it looks like all the requests is coming from the same place, how can we combat that? We'll go into that a little bit. But I just wanted to bring this caveat over here, and then we'll see how we can address that in the future. But in this case, in this scenario, what we can see is that the 10 subnet resource is down. And so the geo module, the GSLB, will not provide a response until that comes back in rotations. When the health check starts passing again, what we'll do is we'll bring it back into rotation, and then from there on, we will start serving traffic to both of the application pools rather than just one of the two. Awesome. Hopefully that helps understand how beneficial GSLB can be in our environment. Now, what are the different types of GSLB deployments that we can leverage? So the options and the architecture is going to depend on our scheduling method. And we have about 5 that we're going to cover in this presentation. The first is going to be round robin, then weighted round robin, fixed weight, proximity and location based, and real server load. So let's get into the first type of architecture. In this case, in this deployment, we're looking at an active type deployment, meaning that we have multiple resources in one geographical location or spread across the globe. Now, this could be on-prem, this can be completely in the cloud, or this can be a hybrid type approach. As we know, there's a massive push to go and have resources in the cloud. So a lot of our DR sites may be located in one of the cloud vendors. And the good thing about us is that we are vendor agnostic. So it doesn't matter which cloud provider that you're using or on-prem, we are agnostic to that, and we will be able to assist in all of those types of deployments. So in this type of deployment with the active, we can either use round robin or weighted round robin. With round robin, it's as simple as it sounds. We're going to have equal distribution of requests that is coming in on the back end. Now, one thing that we just need to make sure and ensure is that we need to have all of the back end IP endpoints having similar resources. Now, if this is not the case, let's say if our production side is a lot beefier than our DR side, what we'll do in that case is that we'll use a weighted round robin. And what it is that we can assign weights and ratios to our back end. So what this means is that I can do a 2-to-1, a 3-to-1, to 4-to-1, meaning that production side is going to get 4 times as many requests as our in this case, not a DR site, but our less resource intensive active sites. So let's say our US site is going to get 4 requests, our EU site is going to get 2 requests, and then our Asia Pacific site is going to get 1 request. This is a type of deployment that we can do with the weighted round robin. Okay, with an active DR type deployment, this is going to be our true production and disaster recovery site. In this case, we're going to use the fixed weighting, where we're going to assign the primary active data center the higher weight and the secondary DR site the lower weight. All of the requests are going to go to the primary side. And when that site is unresponsive or unavailable, we are going to redirect this automatically to our DR site. Now, for those that have been in the IT field long enough, you know how much of a stress reliever this is. We don't have to go ahead and make changes on our NS records to start repointing to the DR sites. We don't have to go ahead and bring up the resources. It does it automatically based on detecting that the primary data center has experienced a failover. Okay, location based. Now, in the location base, we have two options available: location and proximity. So let's go through the location one first, and then we're going to go into the proximity. So with location base, we have sites spread across the globe. And we have two sites in North America. Now, if there is a user that's coming from North America, it's going to round robin between those two sites in North America. Now, as you can see in South America, we have Sao Paulo that went down. Now, in this case, it redirected the traffic and the users from that site to the closest site. And it looks like it's somewhere in the Northeast region, New York, Boston. And so now, if there is a site failure when we're using location based, we can go ahead and redirect the traffic. It's going to redirect the traffic to the closest location. And now if New York went down or Northeast site went down, it's going to redirect the customers to the site in California. Now, when the site in South America does come back online, what it's going to do is that it's going to redirect traffic back to that original site. Now, the way location based scheduling method works is it's country, then continent, then everywhere. Now, what is everywhere? It's IP uh, its IP scheme. So what we can do is that we can create custom locations for IP specific sites. Now, this is very important because let's say if you had a scenario where you wanted to fail the South America site to actually go into South Africa and not North America. Well, if we wanted to do that, then we would use proximity based scheduling method. So what this does is looks at longitude and latitude to determine where the clients are coming from, where they're connecting to, and where the next closest site is. Now, one of the questions might come up is that, Nasir, this is good information, but what about our internal IP addresses? This is great for public IP addresses. And the reason why this is great for public IP addresses is because we have a geodatabase file that knows all of the locations for all of the publicly accessible IP addresses that is coming to us and making requests from us. But what happens to our private site? Well, we're going to define custom locations. And now, remember that conversation about recursive versus iterative? How easy is it that we can just identify the DNS servers rather than creating IP addresses for the entire subnets of the end user clients? Now, 95% of the time, majority of the individuals are using recursive query and not iterative. So that's what we see all the time when we're going through these deployments. So what you would do is that you would put the IP address of your internal DNS server as a custom location, assign that to one of our FQDN mappings, and then when the request is coming from internal sites, it's going to get rerouted to the correct location. Awesome. And next and last but not least, what we'll look at is adaptive base routing. So what does it mean for adaptive base routing? And if you look at the diagram, it's going to be very similar to what we had earlier, which was the active DR type situation. So now in the adaptive base routing, it's going to go ahead and target the primary data center. Well, all the requests that are coming in are going to go to the primary data center. Now, what ends up happening is that we have a massive uptake. There's a local holiday, there's some sort of an event going on, we have some promotion, and our traffic has just, you know, gone threefold or fourfold in the requests that we are usually expecting. In this case, in order for us to not to ensure that we don't accidentally take down the primary data center and bring that site down, what we are going to do is intelligently identify that there is a massive uptake on the request from what we're normally expecting, and then reroute those traffic to the DR site. So it would something look like this, where now you have an even distribution of load to the primary site and the DR site. Now, when this goes back to normal business operation, we're going to reroute this where all of the traffic is going to the primary data center, and the secondary data center then becomes passive. So I hope now that you've looked at all this information, you can go ahead and see how this can be helpful and beneficial for your organization needs in your environment. Now, if you have all of these different load balancers distributed across geographical locations, or you have multiple sites, how do you keep a pulse of all of these different application delivery controller? What we have is something called LoadMaster 360. It's a hosted unified application delivery platform that is designed to provide end users with a single pane of glass experience to deploy, operate, and troubleshoot their application and delivery infrastructure. So what this means is that this is one single stop shop where you can go ahead and keep a pulse on every single application delivery controller, your applications, look at different metrics. So what does it show us? Right. We have usability and experience. We have certificate lifecycle management and automation. I was on a call recently 2 days ago, and we spoke about the lifecycle management. And in the background, there was just a lot of laughter because just the day prior, they were scrambling to renew their certificates because it was expiring. And if you've been in that process of renewing certificates, you know how cumbersome of a task that is. And if you have hundreds of certificates, that pretty much takes up a day or two. And so, what this will allow you to do is just give you time back. Application analytics and telemetry. Being able to identify if there is an issue, if it's a front end issue, if it's a client side issue or server side issue, is indispensable. Configuration management is something that's coming down the line. So what this will allow you to do is make changes across your entire organization from a single platform with a few clicks, rather than logging into each one of the application delivery controllers to go ahead and make changes. Incident management: if something does go wrong, we want to know when it happened, why it happened, were there any other times that these types of incidents had occurred. Right? So and this will provide you with a heat map, policy management and enforcement, least privilege policy, giving access to individuals that need to see it. And this is all available with a single pane of glass. On the left-hand side, you can see um, certain metrics. So let's go into that a little bit deeper. Right? So what do you get from the LoadMaster insight? Oops. Okay, so over here on the right-hand side, you can see the CPU utilization, the memory utilization, the connections per second, the SSL transactions per second, and then transactions per second. So one of the things that I love about this is the SSL transactions per second. There are times where we have exceeded our SSL TPS, but there's no easy way for us to identify that. Well, now we do. Along with that, you'll see the amount of connections that are coming in and how the connections are scaling across our different real servers or across our different applications. You can also see the LoadMaster availability. Did we um, did we experience a failover? Was there anything that is going on with our load balancer? If so, we want to be notified about it so we can remediate that issue before putting it back into the production. And last but not least, we can look at the application level, right? So we want to look at historically, has our backend application server gone down? Were there any issues with those backend application servers? And how often did that happen? Again, just the same way as our application delivery controller, the load balancer is is necessary to keep a pulse on that. Our application just as more. So we need to make sure that both of our application as well as our load balancers are performing at optimal levels. And this is going to give you that. But one of the best pieces of this is going to be that last bullet point. Well, the second last and the last, the HTTP response code insight. So we can see what type of HTTP response code. Are we getting 401s? Are we getting 403s? Are we getting 301s? Are we getting 415? I don't even know what 415 is off the top of my head. But this will give us an understanding as to when we are getting rejected, our clients are not serving or not being able to see, get to the backend application resource pool, what is causing that? Okay, and the last piece is the round trip time and the server response time metric. What if within 30 seconds, I can determine if this is a front end client side issue or if this is a back end server side issue? Well, if I look at my round trip time and my round trip time is, let's say, 70 milliseconds, and my server response time is 700 milliseconds, it's very easy for me to identify that the problem is most likely on the back end, where my server is just taking too long to respond and maybe the server is overloaded. Maybe there's some resources constraint on there. Maybe there's a DDoS attack going on directly on my server. This will save our admin infrastructure, our server guys, a lot of time, and they will love us for it. Okay, and the last piece of it is going to be if we're using SSO, single sign-on, this will let us know from our SSO perspective who is logged in, how long have they been logged in for, if there's any users that are blocked because of failed password attempts, looking at web application firewall, excuse me. If you're using web application firewall, if you want to know if a rule is triggered, why is that rule triggered? Which country or continent are we getting requests from, and is it adhering to our policy or not? The LM360 is a single stop shop for us to get all of this information for all of these various key pieces that we need to ensure our business continuity as well as a healthy environment. Well, here you can find the resources for everything that we've spoken about regarding this presentation. I hope you found this presentation beneficial and helpful. That's it from me. I would love if you are interested to find out more about GSLB and how to leverage GSLB in your organization or even LM360. I would love to speak to you. Please reach out to us. We can get on a call. We can look at your environment and see what would make sense for your environment. Thank you so much for taking time out of your day to listen to me. Let's go into questions if we have any at this time.
Hi, Nasir. So we have a few questions. The first question is all of the examples have been truly global. However, what if I require GSLB within the same city or region? Can location based balancing be that?
Sorry, Rochelle, you broke up towards the end of it, but I got the gist of the question. Is that if I wanted GSLB to be for the local in my particular state, can I leverage GSLB? You absolutely can. We can use is proximity based deployment method for your scenario specifically, and what we can also use is custom locations. So there are two ways to do this. We can use proximity for external IP addresses that are coming in, and for internal, we would use custom locations to go ahead and route traffic between a specific region or a specific local state.
Hi, I have another question for you. So, the question is how can we be sure that GSLB can't be a single point of failure? Do we need to have more than one GSLB for resiliency?
Absolutely. Excellent question. So everything that we do over here, as my job for my day to day, right, is that every time I'm recommending a solution, it's to prevent a single point of failure. So in your local data centers, you would run a HA pair, high availability pair, a pair of two load balancers. But for the GSLB, it is no different. You're spot on the money. What we want to do is we want to have two locations running GSLB on both of them. So in the event that one of the sites, one of the data centers goes down, we do not have a single point of failure, and that the traffic is as working as expected in the secondary site. Because what would end up happening is that, let's say if you had two sites, but you only had load balancing with GSLB on the production side, and if the production site goes down, we are dead in the water over here. So we absolutely would want to have a pair running on each one of our sites to ensure that there is no single point of failure. Excellent question.
And Nasir, this question is fairly similar. How complex is it to deploy GSLB across multiple regions or cloud environments?
It is not complex at all. So just to take you a very high level, so there are two portions of the configuration. One is the configuration on the load balancer itself. The second is on your DNS provider. So so let's start with the DNS provider first. As of right now, without GSLB, you have an FQDN with a record that's directly mapped to it. All we would need to do is delete that entry and create an NS record, the name server record. And what that is doing is that is delegating the response of that to the geo load balancer. So once we've done that, the request comes into the DNS. It's the non-authoritative that we mentioned. It pushes it to the load balancer. In the load balancer configuration, what we have is we have the FQDN with the IP address mapping for those FQDNs, and essentially that's about it.
And this is so far what I see to be our last question. It is what support is available for customers during disaster recovery planning and GSLB implementation?
Excellent question as well. And again, thank you for all these questions. All these questions have been phenomenal, and so I'm so glad that you guys are thinking in the right mindset. As far as support goes, for the load balancer, we have three tiers of support. We have standard, enterprise, and enterprise plus. Enterprise and enterprise plus gives you 24/7 access to our customer support team. We have follow the sun model, where we have the US, the EMEA, and APAC. Before I came into sales, I was in support for 7 years, and I ran the America support team for 3 years. Excellent engineers. So if you have a catastrophic failover, and if you need support, if you're an enterprise or enterprise plus, you can go ahead and reach out to our support team. They're all Progress employees. We don't outsource our support team. As far as implementation goes, we have professional services, and my professional service engineers can help assist you in deploying this across your organization. If you would like to get on a call with me, we can take a look at your environment. I can recommend what type of deployment methods will be best suited for your needs, and the professional service team will help you not only deploy the configuration but help you with pushing that solution implementation into production as well, to ensure that it is extremely very seamless and a smooth process for your organization.
Perfect. At the moment, Nasir, I don't see any additional questions.
Awesome. I didn't put
There's a
my
great
email
comment.
address in there. Yeah, sorry. Go ahead, please.
Yeah, there's a great comment from Matt Reese. He said, Kemp has one of the best support teams I have ever worked with.
Thank you so much.
Thank you.
Really appreciate that. Rochelle, I'm going to go ahead and take that comment for myself, because I was in the support. I was in support for 7 years. So thank you for complimenting me, Matt.
Awesome.
And if anyone has any further questions, apologies. Rochelle, can you just put my email in the chat? If anyone has any questions and they want to reach out to me directly to see how we can, if they want to have us look at their environment, they can reach out to me directly via my email, and we can hop on a call.
Okay, I will absolutely do that. Let's see. So at the moment, there are no additional questions. So I would like to take a moment to thank everyone for joining us today. As I mentioned at the start of today's webinar, you will receive an email containing the recording. And feel free to review the recording or share it with your peers that may also be interested in this topic. In addition, you will receive access to the global server load balancing checklist, and that can be leveraged when deploying or making major changes to your global delivery strategy. And then, of course, join us for our upcoming webinar. We have one scheduled for June 5th, and that webinar is entitled Future Proof Your Load Balancing Strategy for Multi-Cloud and Hybrid Cloud Environments. As requested by Nasir, I am going to place his contact information in the chat for everyone. So that way, if you want to reach out to him directly, you will have his information. Again, I thank you for joining us today. Thank you all.
Thank you all. Have a great rest of your day.
Bye.